here we are. And so a topic, using computer vision to improve accessibility through automated sign language captioning. All right, the cool thing is while we're doing this today, we do have automated captions on the video here. But quick intro on my end. My name is Mohamed, and here's my Twitter and LinkedIn in case you'd like to connect or get in touch about any projects you're working on, or you have any follow-up questions after the discussion. Also, just a link to our blog here and my articles I've written, then also our community forum on Roboflow. And then finally here, we have the link to our knowledge base. And so my role at Roboflow, I'm in developer experience. For those of you that do not know what that is or are wondering what developer experience is, essentially what I do is work with engineers, students, researchers, and just general hobbyists that are hopping on a platform for the first time, and help them learn how to not only use the Roboflow product, but generally understand more how a computer vision model works, how they can customize results, how they can improve a data set, refining a problem statement, or just implementing Roboflow into their own projects on a deeper level. So how did I end up in this role? I started in Roboflow on the sales side. And from there, what we really found was there was that lack or that gap between knowledge of training a computer vision model and actually getting the solution implemented. So that's that piece I'm really trying to fit into now, of helping people get from the point where they have trained a model to the point where they're actually using it, whether that's using it in production, in a work setting, or using it for an internship, or just some kind of side project, or something for a hackathon. All right, so the why behind my actual topic choice. So a lot of you may be wondering why okay, there we go. Sorry about that there. Looks like I'd lost connection here there for a quick second. All right, we'll go ahead and reshare our screen here. So we're talking about the why in this section of why choosing sign language detection. So when you look on Roboflow Universe, for example, you'll find that there are hundreds, thousands of projects. And when I looked in Roboflow Universe for different topics that I could look to present on based off what it seemed that people were highly interested in, or what it seemed that people were really looking to solve, what they found as worldwide problems. And when you type in sign language, you do find a very, very long list of data sets. And the interesting thing was, not only did I find American Sign Language detection data sets, but also found things such as Bengali letters, or the Israeli Sign Language, and Arabic Sign Language. So it seems that this is an issue that people are trying to solve for in many different cultures, in many different localities. And what you find on Roboflow Universe is you can take any project that someone has started on and use it to build upon your own solution. So for my example here, this link at the very top is my data set that you could use to get started. And you could download one of the augmented versions and directly train within your v5, or you could take the raw started on your project too. But it's a very useful way to just look into new use cases and figure out, is this something that's even viable? Because I like to think around that track of, if there's a large number of people making a data set on a topic, or it's more than likely that there's something to that idea. So the other thing here was digging into more of our blog posts when I was trying to wrap my head around the product more last year. I found this article of using computer vision to help deaf and hard of hearing communities. And there's a really striking line in there. And it was, what would you do if you couldn't hear anymore? What if you could only use your hands to communicate? It's a very interesting thought of, most of us don't really think about what the world would be like if there was something such as something we hold dear, if we never had that anymore. And we may always think of that as people, but another thing you could think of is a specific ability. If I suddenly couldn't see anymore, or if I suddenly couldn't hear anymore, what would I do? What solutions would be out there? Of course, there are ways to cope, but at the same time, what if we could make it easier on people to still be able to communicate effectively? When I say effectively, I mean in a shorter amount of time, rather than us saying that, hey, I'm trying to more quickly speak with someone that is deaf or hard of hearing and I don't understand sign language. Let me get them to type out what they're saying so I can understand it. Well, that may seem like a great solution, but at the end of the day, you're really only solving for utility for yourself, because we're really coming from that privileged perspective of, oh yeah, if they can just type it, I'll understand it. Well, that's not their preferred mode of communication. Their preferred mode of communication may be that they would rather sign that phrase or that sentence out to you, because that's the quickest way for them to communicate. And on our end, we're like, oh, well, that inconveniences me. So there needs to be some kind of happy medium maybe in the meantime. And that's why when I was looking at this project, I got that idea of the automated sign language captioning. If I could have some kind of solution where I could point a camera at someone's hands while they're signing, or have augmented reality glasses or something of that sort, I could know more quickly what they are trying to say to me, so that I can respond accordingly, so I can keep that conversation going, so that I can keep that person engaged within the conversation. But also, it could be also a solid way to learn sign language yourself. And why might we want to do that? Well, over 5% of the world's population, or 430 million people, require rehabilitation to address their disabling hearing loss. So disabling hearing loss. So that's not the same as saying that all these people are deaf, but at least over 430 million people in the world have some kind of hearing impairment. And for reference, for those of you that are from the United States, our population is just over 330 million. So far more than the number of people in the US even that require rehabilitation to address their disabling hearing loss. So when thinking of reasons why you may even want to learn sign language or have a solution like this available. And there's more than 70 million deaf people worldwide. Collectively, they use more than 300 different sign languages. So it's one thing for us to solve for the factor of having a sign language detection model, but it's another thing when we want this model to be generalizable to multiple people, so that we can tell what the hands are, no matter what the color of the hands are, no matter what the size of the hands are, no matter if those hands have painted nails on them or not, but also what language is that person signing? Is it American Sign Language, or is it another language? So there are 300 different sign languages out there. If we don't have a proper model, then we're not really going to be able to understand the person anyways, or we can't really implement the solution. So when we're working towards the objective, we're going to need to create a problem statement that is specific, actionable, and measurable. So again, there were over 300 different sign languages. You know, over time, you could have a model that could detect every single one of those languages and translate them. But the other thing that you could do is look at the factor of, what if I really start with one language and perfect that process and then continue to add more from there? So creating a problem statement that is specific, actionable, and measurable. So mine is using computer vision to improve accessibility through automated sign language captioning. What is it that makes this problem statement specific? Well, I'm saying what I'm using, computer vision. Also saying what I want to do, improve accessibility. But also, I'm talking about the actual action there, or how I want to do this, the actionable part. Automating the sign language captioning. And how can you measure whether this solution is successful? Well, there are a few ways. if this was put into an app and someone is using this to learn sign language, you could look at the results for the rate of learning each new sign of what them correctly identifying what is being shown. Another thing is for the actual model's accuracy, as you're going to need to improve this model over time if you see mistakes within it, or false detections or low confidence detections or mistakes in captioning. You can look at an increase in the percent confidence of the actual detections, and an increase in the correctness of the actual captions that are being outputted. The other things too are, if this was an app that was open sourced and available for download, then you could also look at the increase in usage from the number of unique users. As if you have more unique users of the actual platform or the products, then you know that you are improving accessibility as more people are learning about sign language, or at least trying to learn more about sign language. And other factors that had really led me to thinking around how I would create this problem statement were questions that I had asked other people about what they had experienced when they tried to learn sign language, or when they had spoken to someone that was deaf or hard of hearing, or tried to communicate with them. And they said things such as, I don't understand sign language, but I'd like to learn. Or I have a hard time remembering how to sign certain words. Or I find it difficult how to sign longer sentences faster. So the longer sentences faster really helped me come up with the captioning aspect of how I could make this actionable, and also how I could make this measurable. And the speed, well, when you look at model frameworks, YOLO v5, I can get real-time detections out of it. So getting the captions out there faster, that made it really obvious to me that this was a model framework I'd want to look at. And then another thing is hearing questions all the time, or criticisms of one will think such as AR and VR be more useful. So people just really have that idea of, oh, well, you know, I can just use it to play video games, like whatever. That might not be very cool. You could also look at the factor of, you do have products like the Microsoft HoloLens that you can use to visualize things within surgical offices or surgical scenes. But how about if in the future you had a set of AR glasses where you could throw these glasses on and have an embedded device on them, have the model deployed to said device, and see in real time when someone is signing something as the letter M, or signing the letter O, or signing an H, or signing an A, or signing an M, or signing an E, or signing a D, you could see a pop-up either directly below their hand or superimposed in front of their hand, telling you what that actual letter is. So you're knowing that, oh, I'm currently signing my name, signing Mohamed, or maybe I'm signing a full phrase to you, and you can see that in real time. And the other interesting thing is pairing the visual with the text can also help with that aspect of the remembering how to sign certain words. When you're connecting that text to that visual and using it in real time, it's going to be forcing you to actually hold that in your memory better, so that the next time you come across someone signing that, and if you're also practicing your sign language, raise the likelihood that that you can more quickly discern what they're saying to you, and you can reply back to them and keep a more fruitful engagement. So the tools that we'll need for the project. So we're going to need a place to label our data, a place to manage our data sets. So Roboflow is the official dataset management labeling partner for YOLO v5. So when it comes to having that place to label and annotate our images, we have found that. And the next thing is we will also need to train our model. And to do that, we're going to need local storage in a GPU, or we're going to need a cloud service to train these models. And if we're training custom models and we're looking to train multiple models, so we can compare for when we receive the best results and when we're improving detections, so that we can see how we can provide more value, you're going to need a logger. So you can use something like a ClearML, or a weights and biases, or a CommentML. And when you're using these experiment loggers, you'll have dedicated information as a source of truth to tell you at this date and at this time, you know, comparing that to that actual data set version that you have on Roboflow, this is the precision I was receiving, or this is the recall I was receiving, or this is how well the detections were performing on my test set when looking at these training graphs, which can also help you choose when you have created a highly performant model and the model that is more likely to give you accurate captions and detections in the real world. Because we don't want to be giving inaccurate detections, especially with a solution like this. So think of if we gave someone the wrong interpretation that was being signed, they could feel like something offensive was being said, and we obviously don't want that. So another thing you can do when you're creating your actual inference pipeline is setting it so that the detections and the captions that you're outputting are only outputted above a certain confidence level for that detection. So to do that and to make sure that we can version our code and that we can improve upon it, we're going to need a place to host our code. So GitHub will be a great place to do so. And then, of course, pick that model architecture. And for us, in this case, we're choosing YOLO v5 for multiple reasons. One, it's the integrations that we have with Roboflow are just very many of them. And then another thing is that we do have that experiment logger that we can do directly from it. We can do model weights conversion. We can also train in these multiple notebooks and compare our log results to these data set versions. And the importance that we get out of it too is the being able to quickly use those inference results within our pipeline, of having that consistent JSON data that you can say to configure where the actual text is being shown during that detection. If you want to show the text up here or down here, you're going to need to have a consistent framework of where your middle points are or where your bounding boxes are being created from within the code. So with YOLO v5 having that standard library, we do have that information. Another thing that we're able to get when using YOLO v5 is that real-time speed, which is highly, highly important if we're looking to do automated captioning. Because we don't want to get results back to somebody, 10 minutes after the conversation happened, 5 minutes after the conversation happened, or they have to record the video and take it home and then process the frames. No, we would like a solution that we can actually run in real time so that we can continue that conversation rather than starting at one point and coming back later. So this entire process, remember that you're going to need to collect images or video and break up these frames. You're also going to need to organize this data. You're going to need to label it. You're going to need to process your images. You need to train models, whether you use AutoML or YOLO v5. In our case, we'll be using YOLO v5, and we have a notebook available through the Roboflow model library of models.roboflow.com. And you're also going to need a way to deploy your model. So you could be choosing a webcam, you could be choosing a smartphone, you could be choosing a server, you could be choosing an edge device. And you're going to need a way to display your model's results, whether you're just printing that information out to a console, whether you're putting it out on a display, or whether you're showing it within an app, or whether you're displaying it within the camera frame and using something like the OpenCV library with the Pillow library to show the bounding box location or the text location. So all of these parts of the tool chain you can use with the family of partners for YOLO v5 and chiefly with Roboflow as well for labeling and data set management, but also to help you with the model training and the deployment side and displaying your results. So some important things to consider when we're creating our own custom models are, again, the model architecture we're choosing, but different trade-offs of things like precision versus recall, but also that inference speed that we're getting versus the accuracy in our detections. So of course, we do want to have high quality detections. We want to have high confidence detections. So we don't want to have the incorrect information outputted in our captions. We want as good of captions as possible so that people aren't thinking that someone is insulting them when they're not. If you want faster inference, you're going to need smaller model weights. But the thing with that is, again, with the smaller model weights and the faster inference, you may not have as accurate of results. But one thing that you can do to mitigate that is looking at things like improving the class balance, So you can use our dataset health check on Roboflow to look at your class balance. You can also implement active learning to take instances of once you have received your model weights and you begin using detect.py with your output source, whether that's a webcam, an image, a video, screenshot, a directory of images, or parsed video frames into images, a YouTube or live stream source. When you're actually taking that source and running your detections, you can implement active learning with the Roboflow Python SDK. And active learning is that situation where I am smart sampling to mitigate how often I'm receiving false detections in the future. So if I have instances where when I'm signing the word hi, my model is accidentally outputting by, I'm going to want to sample situations where, let's say that detection is happening at 21% confidence. Well, if I set my active learning pipeline to any detection I receive that is under 60% confidence, please take that video frame or image and send that back to my Roboflow workspace. And you could also include the annotation that was applied on that image if you'd like. You can also upload that too, either with our Python package or upload API. Because when you get that annotation that's included, you can then do that Q&A to see, all right, not only was I getting a false detection on this image, but what false detection or detections was I receiving, to help you then create a data set that has more examples of said scene, so that you can create a training pipeline that increases your accuracy while having an improved performance when it comes to speed. So as you're seeing here for the curve for our chart here, YOLO V5 Nano or YOLO V5N is going to give you the highest inference speed. So this is CPU speed, so just regular computer, 45 milliseconds. And what you're seeing here is the mean average precision. So this is at an intersection of union at 50% here would be 45.7, intersection of union for an interval of 50% to 95% confidence interval would be 28%. And while it does seem low, again, this is going to depend on the type of data set you've created and the number of classes that are within your project, as this is on the COCO data set, which is over 80 classes. So if we're focusing on just 1 or 2 or 3 classes, or let's say that this was a sign language detection model where we weren't wanting to recognize every single phrase within ASL, but just some key phrases, then we could still end up having a better performance for our mean average precision. So other things that we'll need to do: exploring deployment options that enhance the experience. So there are other papers that have used YOLO V5 for things such as augmented reality applications. So here's one I've linked in this presentation of augmented reality for a maintenance assistant using YOLO V5. And then the next steps from here are doing things like thinking to yourself, what kind of project would I like to do, and what problem statement would I apply to make sure this is a project that is viable. Again, looking at what is specific, actionable, and measurable for that problem statement. And then you can go to Roboflow Universe if you find that you don't have images or you don't have enough images to help you get started. And you can look within our actual categories on our browse page to help you find better ideas for your use case or a topic to get started, or even to just find a data set as a baseline for your project. And then the next things are that if you're needing more resources to continue with your project and you're not working with a company, so you don't have a budget for it, and you're just needing like a research project, or you're a student looking to do a capstone project, or maybe you're just a hobbyist getting started in the space, we do have a community option. So more than happy to support those community projects. And being in developer experience, I'll be the person replying to you, and we'll just want to know a little bit more about what you're trying to accomplish so that we can help you along the way and get your project to completion, whether that's something building an autonomous vehicle with object detection, or dangerous monitoring for cyclists using Raspberry Pi and object detection, or using computer vision to win a Super Bowl game, or a Vine Inspector, the Vineyard Assistant, or doing other intensive studies for your research. So it doesn't have to be something as big as sign language detection and creating a model to detect 300 different sign languages. We do have a question here in the chat of how many images would you recommend taking of the letter K, for example, inside of the same place? So that's a function of variability. And when I say function of variability, I mean it really depends on the total number of classes within your project. If you're looking to detect 26 different letters, then you're going to want to look at something like Roboflow's dataset health check tool. Here, let me show you an example from my project. So here's my project here, and when you look at my health check, you'll see that when you see K, just 27 examples in here. And what I did is I used a very large augmentation multiple, which is how I ended up getting more examples. Well, that letter K, you just want to make sure it's with a good class balance with the other classes within your project. But for training tips for YOLO v5, they're actually training tips directly on the repository. So tips for best training results. But the other thing I would really focus on, again, is just looking at your class balance, getting some null image examples in there. And what you can do is use one of your free Roboflow training credits to just train a one-off model and see how that model is performing in real time with your webcam or with the deploy tab. And then from there, use active learning to do smart sampling. Because from smart sampling, you'll be able to use that function of variability aspect that I said again, but have that factor of now I can improve my model with fewer images, because if I just add 1,000 more annotations of the K class, I may end up just completely overfitting. I want to just sample to the point where I have as few additions as possible to the data set overall. Hope that made sense, but if you do have more questions on this end, happy to set a meeting time or correspond via email on this project that you're looking at. Do we have any other questions that anyone would like to ask, or anyone else in the chat looking to get something answered? All right. Just want to say thank you very much for listening and tuning in. And again, if anyone is looking to get started on a project and needing more resources to get started, you have universe.roboflow.com, and then sign up for the app via app.roboflow.com. And if you're needing any credits, roboflow.com/community, and I'm more than happy to assist. Thank you very much for attending. Bye.